gonna solve a problem based on exact differential equation. So guys, here we have a question as x dx plus y dy equal to a into x dy minus y dx whole upon x square plus y square. Now guys, to get a solution of this differential equation, we have many methods. So the question is, if we want to solve it by exact differential equation, then we have to check the condition of exact differential equation. So if it is satisfying that condition, then we say that the given differential equation is exact, and then we can find out the solution. So for that, we have to convert the equation in the form m dx plus n dy equals to 0, because this equation is said to be exact if dou m by dou y is equal to dou n by dou x. So to convert into this form, what I'll do is I will take all dx terms together and all dy terms together. So here we will get, therefore x dx plus y dy equal to, this will be ax upon x square plus y square dy minus ay upon x square plus y square dx. Now this dx will come on LHS and that will become positive, so we will get x plus ay upon x square plus y square into dx, plus this will come on LHS and that will become negative, so y minus ax upon x square plus y square dy equals to 0. And now we got it in the form m dx plus n dy equal to 0. So here I can say that, therefore comparing with m dx plus n dy equal to 0 form, we will get the value of m as x plus ay upon x square plus y square, and the value of n as y minus ax upon x square plus y square. Now guys, here from m and n we can get the value of dou m upon dou y and dou n upon dou x, and if these two values are same, then we can say that the given differential equation is exact. So for that I have to differentiate this m with respect to y partially. So here I'll say, therefore dou m upon dou y equal to. So guys, the x will be treated as constant, so the differentiation of x with respect to y partially is 0. Here a is constant, I can take it outside, and for y upon x square plus y square we have to apply the u upon v rule. So a is outside, and in the bracket we will get here x square plus y square, that is v term, then the derivative of this y with respect to y, that is 1, minus y term as it is, and then the partial differentiation of x square plus y square with respect to y. So for x square it is 0 and for y square it is 2y upon x square plus y square the whole square. Now let's simplify this. So here this will become minus 2y square and we have plus y square, so that will become minus y square. So we'll get a into x square minus y square upon x square plus y square the whole square. So this is the value of dou m upon dou y. Now let's find out the value of dou n upon dou x. So therefore dou n upon dou x equal to, so for that we'll differentiate this n with respect to x partially. So differentiation of y with respect to x partial is 0, and here we'll apply the rule of u upon v by taking minus a outside. So minus a outside, in the bracket we'll use u by v rule. So x square plus y square as it is, differentiation of x is 1 minus x as it is, and differentiation is 2x, and here x square plus y square the whole square. Now guys, here we will get minus 2x square, and this x square will become minus x square. So minus x square and positive y square. Now if I take this negative sign inside, so this y square will become negative y square, and that negative x square will become positive x square. So we will get a into x square minus y square upon x square plus y square the whole square. And guys, here you can see the value of dou n by dou x as same as dou m by dou y. So since these two values are same, we can say that the given differential equation is exact. So if the given differential equation is exact, then we can get the solution by the method of exact differential equation. So the solution is given by one of these two formula. So I'll use the first formula. So it says integration of m dx by treating y constant plus integration of n with respect to y by just considering the terms which are free from x. So here m dx. So guys, here I'll say therefore its solution is given by integration of m dx. So what is value of m? So guys, this is the value of m. I'll integrate this with respect to x. So x plus ay upon x square plus y square into dx plus integration of n dy. So this is the value of n, and we say that we just consider the terms which are free from x in the value of n. So here in this value of n we have y which is free from x. So here I'll say y dy equals to c. So let's integrate. So here the integration of x with respect to x is x square by 2 plus ay constant outside, integration of x square plus y square, that is 1 upon x square plus y square, is 1 by a, that is 1 upon y, tan inverse of x upon y, plus integration of y is y square by 2 equals to c. So it will be cancelled. So therefore we will get x square by 2 plus a into tan inverse of x by y plus y square by 2 equals to c. So guys, this is the solution of the given differential equation. So here we have seen that how to solve the differential equation by the method of exact differential equation, and I'm sure that you like this video and you want to learn more videos on exact differential equation and the concept of engineering mathematics. So don't forget to log in to ekeeda.com to get access to all videos of engineering mathematics. Thank you very much.